Hello. So this is 7.04 Learning Check. You have substance that starts at 5 degrees C and 25 millimeters of mercury and ended at 0.01 atmospheres and what temperature. Okay. So you're going to figure out which law, what was held constant or assumed constant because the information was not in the problem, and finally, what is the answer rounded to proper sig figs. Go ahead and hit pause. And welcome back. So the first thing that you need to be able to do is know the gas law triangle. And that is that guy right down here. And now let's make sure we can label parts. A substance started at 5 degrees C. Okay, so it started at temperature. So that's a temperature 1. And it started at 25 millimeters of mercury. Millimeters of mercury is a pressure. Its starting one is at 1. 1 is your start. 2 is your end. And they could also be called initial and final. It ended at atmospheres, not at the moment. Atmospheres is the pressure. That's my end pressure, so it's pressure 2. And the one with the question is our unknown. Okay, and it's the unknown for temperature. So that would be temperature 2. So I have pressure and temperature. What don't they mention at all? Volume. So we're going to assume volume was held constant. What law is it? It's a law that deals with pressure and temperature. Gay-Lussac's law. What is the equation for that? The P is over the T. So P over T is your code word. P1 over T1 equals P2 over T2. That's my formula. Remember, we have to compare apples and apples. And temperature always has to be in what? Kelvin. Pressure always has to be apples and apples, the same. If we had a volume, the volume would have to be apples and apples. It does not have to be liters like in module 6. Okay, so we got some converting to do here. So some side quests. 5 degrees C. So temperature 1 is equal to 5 degrees C. How do I convert it to Kelvin? Add 273. Temperature 2 is what we need to find for. So my answer for temperature 2 is going to be in Kelvin, and then I'm going to have to convert back. If not, your equation won't work out because this is not dimensional analysis for temperature. It's adding, so you have to convert to Kelvin each time. Okay. And now I have my choice of atmospheres or milligrams of mercury. So I can convert either way that I want to. Okay. So I'm just going to start with 0.01 atmospheres over 1. Atmospheres is my known, so I'm going to put it on the bottom. Milligrams of mercury is my unknown, so it goes on my top. Unknown over known, same thing we've been doing all along. And now I need to know my conversion factor. 1 atmosphere is equal to 760 millimeters of mercury. So why did I pick atmospheres to go to? Because I wanted the 1 on the bottom. Less work for me to do and less chance that I mess up when I'm dividing. Okay, atmospheres cancel. 760 times 0.001. Okay, so that would be 7.6 millimeters of mercury would be my answer. Okay. And if you wanted to do it to be technical, it should only be 1 sig fig, right? So 8 millimeters of mercury. What is 8 millimeters of mercury? It goes in place of pressure 2. Okay, so that is my pressure 2. 25 is my pressure 1. So side quest over. Pressure 1 is 25. Temperature 1 is 278. Pressure 2 is 8. Temperature 2 is what we're solving for. Cross multiply and divide. 8 times 278 divided by 25. Okay, if you don't know how to do it that way, you can use your normal algebra to also do it. 278 times 8 divided by 25. That gives me a T2. I'm going to write it over here. A T2 of 88.96. What units are those? Kelvin. I need to do what? Subtract 273 to get it into Celsius. So my answer is going to be negative 184.04 degrees Celsius. But look at this. I only have 1 sig fig, 2 sig figs, 1 sig fig. So that negative 184 is going to round to negative 200 degrees C for your answer. If you didn't get it, go ahead and restart it and try again. Remember, you need your notes down as well as one thing you learned. Have a good day.